Hello, everyone, and welcome to today's workshop, Building a Netflix Clone. I'm Ryan Welford, and I'm joined by Cedric Lundven. Hello, Cedric.
Hello, Ryan. Hello, everyone. Happy to be here with you for this 2 hours workshop. Today, we will discuss about React, GraphQL, and a lot of great things.
Yes. So if you can see us and hear us clearly, give us a thumbs up in the chat just so we know that everything is working as we expect. And if there's any issues, we can fix them. But with that, let's go ahead and get started. There's echo. Uh-oh. Is it echo when Cedric talks? I might have to change something.
Echo, echo, echo.
I'll try and narrow that down in a little bit.
Okay, yeah.
So as I said, I'm Ryan Welford. I am a developer advocate here at DataStax, and Cedric is our director of developer advocacy, and we are definitely nerds and experts at Cassandra.
As you can see, I'm all into Java. Today we will discuss more about JavaScript. So yes, Ryan will take the lead.
That's my world, yeah. But it's not just us. We actually have a whole team of people here that are ready to answer your questions. We have a few people in the chat that will answer your questions. Obviously, Cedric and I will also answer your questions in chat. But we also have a Discord where all of us are very involved, and it's a great place to ask questions throughout, your learning and outside of workshop times. So we'll get some details on that in just a second. All right, it looks like there is no echo for most people, and we have a lot of thumbs up. Awesome.
Nice.
Awesome. Okay. So just a little bit of housekeeping. We are streaming both on YouTube and Twitch. But if you are on Twitch, we are not really monitoring the chat there. So if you have any questions, make sure you ask in the YouTube chat or on our Discord. Twitch is really just kind of backup in case YouTube has some streaming issues. For the Discord, you can actually type a command in the chat, !Discord, and you can get a link to our Discord if you would like to join. It is a growing community, and we've kind of revamped it recently to kind of cater more towards a lot of different areas of development. And we answer questions in Discord as well during the workshops and outside of the workshops. If you have any issues with some of the homeworks or any questions of your own personal projects that have to do with Cassandra or Astra or really anything, you can go there and ask those questions and just be a part of the community. It's a really good place. Yeah, go ahead, Cedric.
And I think on Discord, we are about to reach 18,000 people.
Wow.
So, go there. It's all about learning, streaming as well, Cassandra. And, if you got any issue during the workshop, because you will do exercise today, you will do the hands-on, I promise. You can copy, paste the technical stack there. It's easier for one-to-one debugging.
Yes, definitely easier for troubleshooting. So we are going to be playing a game today. We're going to start with a little quiz right at the front to get to know you. And then at the end, we will have a game where you can win some prizes. And we're going to be using menti.com for that. And we will guide you through how to get in there and get a link to that. It's an online quiz thing that you can use on your phone or on your computer. And it's really easy to use, but just to give you a forewarning. So hands-on, we are going to be using GitHub. We have a GitHub repo that is hosting all of our content. You can type in !GitHub to get the link to that. That is where we're pretty much going to be going through that GitHub repo. It is designed to be self-service, so if at any point you have to leave the stream for any reason and you want to come back to it, the stream is recorded. You can watch it later. You can also go to the GitHub and kind of work through it at your own pace if you would like as well. We are going to be using a tool called Gitpod, which integrates really well with GitHub, and it is a cloud-based IDE. It's actually based on VS Code, so if you are used to VS Code, it will be very, very familiar. One of the reasons that we use Gitpod is it allows us to craft a very specific environment that we know works. So if, it kind of reduces the hurdles that might come up if you're using a local environment. If you want to work locally, you are absolutely welcome to do so. There is some information in the GitHub repo on some of the versions of NPM or Node that we use. We recommend using those versions. And if you are working locally and have any issues, our ability to troubleshoot is a little bit limited. We absolutely will attempt to help you out. And the best place to get help with that is on our Discord.
Yep.
But Gitpod just lets us like give a very specific environment that we know works. And we're going to be using Netlify. Netlify is a global CDN and hosting solution for web apps. We're going to be using this to utilize serverless functions in our app. And we're actually going to be using the Netlify CLI in our development environment so that we can run our app locally as if it were hosted on Netlify. There is some instructions in the GitHub repo to deploy to Netlify if you are interested in doing that. We will not be doing that today, but there are instructions on how to do that. And then finally, we'll be using AstraDB as our database. AstraDB is a database as a service based on Apache Cassandra. It is free to get started. There is a $25 a month credit system, which is enough to run a small to medium-sized business off of. So really easy to use, and we'll walk you through how to use it. It's really, really cool. All right. So the difficulty of this workshop is going to be pretty easy. It is designed for beginners to intermediates. We will walk you through all of the code. We won't be doing a ton of in-depth React or JavaScript code. We're going to be focusing on kind of the structure of the data itself and using the GraphQL API from our front end to query that data and get it ingested and used in our front end. We will walk through all the steps, and if you want to dive deeper into the code, all the code is hosted on our GitHub, and you can dive into it deeper at your own pace. All right, so we actually offer badges for participating in our workshops. This is a growing collection. I think there's like 6 more that I haven't even realized we have.
Yeah, we have about 70 badges now. So as you can see, we are doing a lot of workshop. You will see it's all about interactivity. You are doing the work with us. And in the end, if you do the homework, it's easy. You get the badge. And there is a lot of badges, as you can see. And, so that's also show you all the topics we are able to cover on the channel every weeks on Wednesday.
Yeah, and it's a really good way to show your continued learning. You can put these badges on your social media, on your LinkedIn profile, and it's a really good way to show that you're continuing your learning and kind of show off what you're able to do. And yeah, like Cedric said, all of these badges are examples of workshops that we've done, and all of our workshops are recorded and hosted on YouTube. You can watch any of the previous recordings, and we regularly do live versions of these workshops again. So definitely, if you see anything that you're interested in, go look for those or keep apprised of what's coming up. All right, with that, let's go ahead and do our first Menti. So if you type in !Menti, there will be a link that you can go to connect to our Menti quiz. Let me switch over to it.
Mm-hmm.
And let me get some music going. Otherwise, it's really quiet. So Menti, this is going to be just a couple of questions to get to know you, and kind of help us craft this workshop to make sure that we're focusing in on the correct things. We will be doing the game for prizes later, so this is not for prizes at the moment. So don't worry.
Yeah, for now it's just easy question to set the expectations. Also, I told you if it's the first time you attend one of those workshops, it's interactive. We will ask you question now. So open a new tab, go to menti.com, use the link, and we will ask you question live. And please leave this tab open up to the end, because at the end of the workshop, we are doing a quiz, a competition. And if you answer fast and get in the leaderboard, you will get some swag for free. But as of now, as said by Ryan, is few questions, no competition, no goals, anything.
Yes. All right. So our first question is, where are you from? It's always a really cool to see the dots pop up and see how
are you
spread out everyone is.
Is it the morning, the evening, the afternoon? Okay, it's spread across multiple continents. You know, we are live all across the world. That's amazing. You
Yeah,
know?
it's really amazing. And
Yeah, you
Cedric's in
realize
France.
that. Wow.
I'm in Texas. It's really cool.
And I'm based in France,
Yeah. All right, so we got
Philadelphia.
several people in India. We got a bunch of people from Europe, South America, North America, a couple in Africa, or at least one. That's really cool.
Thank you. Yeah, thank you, everyone. Yeah, for some it's pretty late already. So the workshop will be for 2 hours, and it's recorded. So if you have to leave before the end, you can reuse the same link, and you'll get the recording. But you know, if you can, stay up to the end to play the game.
Awesome. All right. Jackie Soth asks, "What is the code to join Menti Quiz?"
Yeah,
you can
I
get a
shared
link.
the link.
Yeah. You just click the link. All right. Next question: how much experience do you have with GraphQL? Are you a complete beginner? Are you comfortable? Considered an expert, or did you create GraphQL? That's an option too. If
That's it. Okay, if someone creates GraphQL,
oh, we got
send
the
us
creator.
your Skype, and we will call you and put you on screen.
Yeah, definitely. You'll be able to talk.
You will run the rest of the workshop.
All right. Most people are complete beginners. That's good. We're going to be going over the basics of GraphQL, try to get you familiar with how to use GraphQL. Not super deep. We actually have a separate workshop for going super deep into GraphQL, but we'll get some practical use out of it. It'll be a really good introduction for sure. All right. So are you familiar with React? Our front end is built in React. We're not going to go super deep into it. We want to know, how much we need to explain some of the concepts. So it looks like it's about 50-50 right now. Maybe majority have used React and are familiar with it. That's good. That's really good. So we can focus in on using that GraphQL API and how to use that from our front end in React. All right. Awesome. Well, thank you very much. We're going to leave the Menti there, and we'll do the quiz later. Thank you for participating. You can leave Menti open if you have it open on your phone or on another tab. Just leave it there, and it'll be easier to get going for the quiz. So with that, I'm going to hand it over to Cedric.
Okay, right. Great. So waiting for my screen to be on.
You got it.
And okay, just waiting for the feedback. Okay, look like I'm on. Okay, so you have seen with the title that we will build a digital library with thousands of entries. Woo, spooky title. So today we will create a clone of Netflix. So what I'm showing right now on screen is exactly what you will have on your laptop for your application at the end of this 2 hours. Okay, it's a clone, so you can just navigate the movie, just look at the teaser. Sorry, not playing the actual movie. It's all open source data. We don't have the rights to play those movies, just the teaser. Okay, but that's still pretty cool to see that you will be able to create that real app. Okay, so let's get rolling. Very few theory in the beginning. This workshop is all about you working and interactivity, but just set the scene. So we are building a full stack application. Full stack application means you will have 3 layers of front end, the user interface, a backend. Most of the time it's an API, REST, GraphQL, gRPC, multiple flavors of APIs, and a database. And again, multiple flavors database could be relational, NoSQL. Today we will use a NoSQL database. So it's what we call the logical architectures layer. But the component we will run today, we will have one component which is running. This is our application. So the user interface and part of the API will be in the same runtime. This is the Node.js React runtime. And you will see that at the database level, to avoid learning how to interact with the database, the drivers and binary communication, at the database, we already have an API to expose data. So if I put the names of the technology for today, the database will be a NoSQL database called Cassandra. On top of Cassandra, we will have a GraphQL API that you will use, you will learn and how to use. You will use it, okay? And then on top of this GraphQL API, the app I've just shown you, this app using the GraphQL and to display those nice genre and movies. In the database, we do have 6,000 movies titles. So it's, quite some large data set. And let's have fun with that. So the agenda, super easy. We will move from the database up to the user interface. Each layer, each component is a chapter. Okay, it's all about technical and real stuff. No marketing here during this session. And without further ado, we can go right into step one, the database. I want you to create the database first. This one will take a few minutes to initialize. So this is why also we would like to start with the database first. So I would like you to go to GitHub and using the alias !GitHub to get the GitHub repo with the code and also a README, extensive README with all these instructions. So this is what the README look like. So it's DataStax Dev Organization, GraphQL Netflix. So I will copy a few times the URL in the chat right now. You do have the README with extensive step-by-step. And with Ryan, pretty soon we will go with part one. Step one, create a DastraDB instance. Okay, so I will let you go there. And as you can see, I do have on the left part of my screen, the README always open. And on the right part, I do have the database screen. And this is where I will be able to run all the instruction. Ryan will do the same. So you will see that the first step asked during the README is to locate the button create AstraDB in the README, and that will route you to astra.datastas.com to create the Astra instance. Okay? And I think that's a good first step. I will let you go and hang back to Ryan.
All right. Thank you, Cedric. All right, so if you go to the GitHub repo, and I am starting here in part one, and we're going to be creating the AstraDB database. So this big orange button, if you click that, it'll bring you to this page over here on the right. And we're going to log in. You can sign in or sign up with a GitHub account or a Google account or just a regular email and password. It's pretty easy. I've already got a Google account, so I'm just going to sign in with Google. It might ask you a very short survey question on your use case for Astra. I believe one of the options is education or learning. That's always a good option.
Yeah, always learning. We will be soon in the learning period. Beginning of the year, everyone would like to learn new things, and we will be there for a boot camp to learn everything you need to know about the Cassandra database.
All right, I'm just realizing that some of my databases still exist, so I'm just terminating them. Doing some cleanup. Okay, so once you have logged in, you will see a page that looks similar to this. You won't have any databases created. That's fine, unless you have created an account already. You might have a database created already. That is also fine. The easiest way to get started next is to click on, there's a button up here, or this big blue button on the right here. Let me zoom in my screen a little bit. That might help. So there's a create serverless database. You can click on that. And it's a really quick 3-step process to create a database. We need a database name, we need a key space name, and then we need to select the provider and region. Now, a key space is similar to a schema if you're coming from the relational world, or a namespace is sometimes what it's called if you're familiar with that. It's just kind of a collection of tables that we're creating. So we're going to use some predetermined values for the table and key space. We really recommend using these because there is some code already created in our repo that assumes these names. If you want to use your own, you can. You're just going to have to go and change it elsewhere as well. So easiest way forward is just to use these names. So database name, workshops, and our key space name will be Netflix. And then for the provider and region, you can select whatever you want. You do not need an account with any of these providers. All of that is handled by Astra. We suggest to choose just a provider of your choice and a region that is closest to you. So I'm going to choose US Central. But any region and any provider should be totally fine. And then go ahead and click Create Database. Now, you may have noticed, and I'm actually going to go back there and show this. So you may have noticed when you select a region, oh, actually, it doesn't show that anymore. Never mind. It used to show the cost from the provider. It doesn't do that anymore, which is good.
Yeah, but now there is no cost. If you do not use 40 million queries a month, it's totally free for you. Okay, so we are using a web-based tool, a cloud-based database, that it's free up to 40 million queries per month, and those 40 million are renew every single month. So that's cool. And it won't get terminated anytime soon. So if you are a student and would like to have a database for free, hey, this is a good candidate.
Yeah, and you can see that reflected in the credits remaining. Everyone should have, I believe, $25 in their credits remaining, and that will be refreshed every single month. So you don't have to worry about the cost. It is completely free. You don't need to enter a credit card at all to get this going. So as you can see, I have my workshops DB. This is the second line here, and it is currently pending. It'll take a couple minutes to go from pending to active, but we can just let that go, and I'll send it back to Cedric to continue the slides. But if everyone has gotten to this point where we're waiting for the database to spin up, give us a thumbs up in the chat, just so we can make sure that we don't need to repeat any steps. Arjit Gower asks about the badge. It's the same. Yes, this is the Netflix.
Full disclosure, we tried with a new title to see which one performed the better. Is it technology, use case, or stuff like that? Yeah. Okay, so you do have the database pending. That's cool. Oh, I can see some names, returning names. So Kwanggung Choi. Hope I do not scorch your name. Thank you for coming back. I remember you were there last week. Okay, so all good. So see also that I do have my screen sharing back. Again, few slides and you can go back to end zone. I think I only have very few slides. Okay, so you will create the database in Astra. On the Astra DB platform, you can interact with the database using the driver. To connect to Cassandra, you use something called the CQL, Cassandra Query Language, which is pretty close from SQL. It's a subset of SQL, but it's not relational. It's not exactly the same way to design tables. Still, today, the purpose is to build a front-end application, and front-end would like to interact with APIs, get my data, save my data. And in Astra, you already have multiple APIs. You have a REST API, a GraphQL API, and even others API, gRPC. Today, we will use the GraphQL API. So GraphQL has been created by Facebook in 2012, so that's 9 years ago, but it was really became more in use or more famous since GitHub announced that the GitHub API v3 will be all about GraphQL. So it's a new way to expose some APIs over HTTP. So what is the difference? Well, when you work with GraphQL, first you define your entities. So here on screen, you see you describe your data. Here you do have a sample object called project. Then you will list all the functions that you can do on your entities, like create, update, delete, doing some dedicated computation. Expose those functions inside a schema. So a GraphQL endpoint will expose the schema with everything available, all the entities, all the operations, and you will see in a minute how it works. As soon as it's set up, you have a single endpoint, and you will create some queries to get the data, mutation to edit the data, and when you build your request, your query, you can exactly request what you need. It's not like REST. If I invoke a REST endpoint, I will always have the same payload, the same output, and it could be very verbose. Here with GraphQL, you can say, hey, okay, give me the list of projects, but do not give me all the attributes. It would be too many, and on my screen, I only need 3, for instance. That will reduce the payload and the network traffic you will have between your app and the API. So that's pretty good when you want to build some mobile app, for instance. Okay. Again, you will learning by doing, but with this new way of exposing API, the great things is the discoverability. You invoke the endpoint and you can ask, hey, what are all the entities available? What are all the functions available? And start introspect and see what's happening. You invoke exactly what you need, so reduce the payload. You have some flexible versioning, okay? You can work with multiple version of the entity. It's backward compatible because you only ask what you need. So if you add fields, they were not in previous request, you can just update the request and they will be there. And it's matching the standard. It's still invoking some JSON over HTTP. So, okay, easy. Now, it's a single endpoint. So it's not easy to say /user, /my user ID just to access one user in particular. You will invoke always the same endpoint. And if you want to do fine-grained security, I would like my user to, I would like my consumer accessing this resource to be admin, to have admin permission, and this other resource with my users to have, I don't know, just users permission. It's not really simple to do that with GraphQL because everything is exposed with the same endpoint. To do so, you will have multiple GraphQL APIs. Not so good. It could be complex to implement if you want to code your own GraphQL API. Fortunately, it's done for you. It could be hard at the server level. Again, you just consume the data for today, and it's not easy to cache. So what the use case for this guy? Service aggregation composition when the bandwidth is key, like on mobile. And it's a good way to build some backend for frontend because you will return exactly the data needed for your screens and nothing more. Guess what? This is exactly what we do today. So let's use GraphQL API exposed by Astra. So AstraDB, your database should be active by now. You have created a 3-node cluster Cassandra cluster. You have no ID, but just by clicking create new instance, you have a distributed database with 3 nodes. On top of this database, we do have a proxy, what we call a data gateway, exposing the API REST GraphQL. And so in the next hands-on, you will navigate the GraphQL endpoint using a tool, a web user interface tool called GraphQL Playground. So GraphQL API, GraphQL Playground. With these two tools, your job now is to create the table we need, import the data we need. I mean, just initialize the database totally. And when you will done with that data ingestion, we will come back and start coding. Okay, now back to you. Let's fill this database.
All right. So going back to our GitHub repo, I am now on step 2. One of the things that we have to do first before we can use the GraphQL playground to play around with the API is we need to generate a security token because we need to authenticate that communication between our database and the playground. This security token is also going to be used in our app so that we can get our front-end app to communicate as well. So to do that, the easiest way is now you have your database. It should be active. On the far right, if you scroll all the way over, there is this ellipses menu button. If you click on that, there should be an option for generate a token. So go ahead and click that. It should bring you to this page. Now we're going to generate a token. We're going to give it the database administrator role, which is a pretty high level role. This is just to make sure that we have all of our permissions to do some of the things that we're going to do. We're going to be creating tables. We're going to be inserting data. So database administrator is kind of the easiest way to get all those permissions right away. So go ahead and click generate token and it will generate your token. Now we're really interested in this last field, this token field. Actually, I'm going to zoom in a little bit, like one. Oh, there we go.
Yes.
We're interested in this last field. These other two we don't really need at this time. One thing to note, you can use this widget to copy. We recommend downloading the token details. This will download a CSV with all these details in it, because if you navigate away from this page, or if the page refreshes or whatnot, it will not show this to you again. It's a kind of a security feature that if you navigate away, it will not show you this again, and you'll have to generate a new token, which is fine. But the easiest way, download token details. I'm going to try and keep this window open, but I'm going to download the details just in case. Okay.
Yes. And this token, we will use it everywhere. So, make time, take the time to get it, copy it, and save it somewhere on a text file or something you can use again and again. All
right. So I'm going to go back to my dashboard. I just opened it in a new tab, so I can try and keep that window open. And now I'm going to navigate. Yeah, we'll see. About 50-50 whether it stays open for me. So I'm going to click into my workshops database that I created here. And I'm going to go up to the connect tab. See, there's a few tabs up at the top. I'm going to click on connect. And then on the left side, there should be a GraphQL API section. I'm going to click that. And now we have a link to our GraphQL playground. Just make sure I'm where I need to be. So this is a link. This is a unique link for each person. So I can't give you the link to it. You'll have to navigate here yourself and go ahead and click this link, and it will open the GraphQL playground in a new tab. Make it big. And now this is what we're going to be using to kind of illustrate how GraphQL works. So if everyone is to this point and has generated their token and has found the GraphQL playground, give us a thumbs up so we know we're not leaving people behind.
Yes.
All right. So while I'm waiting for those thumbs up, I do want to kind of go over. Awesome, David. Okay, yeah, Yasmin is still trying to get it. While you're navigating to those points, again, all those instructions on where to find the links and stuff is in the GitHub repo, so you can reference that as well. But I want to give an overview on how the playground works, because it's a little it can be a little confusing, because there's two tabs. There's the GraphQL schema tab, and then there's this GraphQL tab. And we're going to be using both tabs for different things. The GraphQL schema tab is where we're going to do our DDL commands, or data definition commands. So this is where we're going to create tables, edit our schema, anything like that is going to be done in this first tab. And then all of our kind of queries, our DML commands are going to be in the second tab. Querying data, inserting data into tables, all of that will be in the second tab. So we will be jumping back and forth. I just want to illustrate that there are 2 tabs and to keep that in mind. And I'll let you know when we're moving to different tabs. But sometimes you'll try and execute a command and it'll fail and you'll wonder why. Sometimes it's because you're in the wrong tab. All right. So I see a bunch of thumbs up. I see Cedric is helping.
And I shared with Yasmin how to find the GraphQL playground link.
Perfect. Okay, so the first thing that we need to do in the playground is insert our token that we generated to authenticate. So at the bottom, you see this HTTP headers. If you click that and open it up, you'll see the token section and then this part that says populate me. So just highlight populate me and paste in the token that you generated, which I have copied already. And that should be all we need to do for this tab. We'll actually have to do that again in the other tab, but we'll do that later. So now that we have our token and have authenticated, you can see that server cannot be reached is gone. The error is gone. Everything is connected correctly. The first thing that we're going to do is create a table. So we can actually do that through the GraphQL API. And you can see I'm now in step 3C on the GitHub repo. You see we have a mutation command here. So anytime that we are altering things with the GraphQL API, whether we're creating a table or we're inserting data, that is a mutation command. So we execute that by starting with the mutation, and then we define what we want to do. I'm going to just copy this over to the playground, and then I'll kind of walk through it a little bit. Should be a little bit easier to read with the colors. So what we're doing here is we're creating a mutation. We're naming the mutation. So we're calling this reference list. This is just the name of the command that we're doing. And the specific command we're doing is create table. So this is going to create a table. We have to give it our key space name. If you remember, we created a key space in our database and we called it Netflix. So we're giving it the key space name of where we want this table to be created. And then we're defining the table name and we're calling it reference list. And then we're stating if not exists. So if it already exists, it's not going to do anything, right? We don't want to overwrite anything. And then we're giving it two things. And these are actually defining the columns, but they're called partition keys and clustering keys. And I'm not going to go into depth on what those are specifically. We have another workshop that goes into, it's our intro to Cassandra that talks about what partition keys and what clustering keys are and what they do. But essentially, this is where we're defining our columns. So we're defining a column called label, and then the data type is text. And I'm about to sneeze, so I apologize in advance. It's just hanging there. That's the worst. And then we're defining another column, and we're putting it in the clustering keys. Again, I'm not going to go into detail on what that is quite yet. Maybe in the other table I will. We're defining the name as value, and the data type is text, and then the order is ascending. So this is actually going to store that data on disk in a specific order. In this case, ascending based on the name. So that's how the mutation create table works. And now that we have it in here, we can click on the big play button. And you can see it execute, and it's just going to send us back reference list, which is the name of our mutation, right? True, right? So basically telling us that mutation succeeded, which is good. That's what we'd like to see. All right. So now we're moving on to step 4 in the GitHub repo, and we're going to insert some data in this table that we just created, which means we're going to use the other tab, the second tab, this GraphQL tab up here. Go ahead and move to that. Now we have the server cannot be reached and an error because we need our token. So HTTP headers at the bottom, we're going to open that. And I need to copy my token again, which you could probably copy out of the other tab as well.
Yes, so you might ask, why do we have two tabs? The first tab, as you can see, is named GraphQL Schema, and it's all about just doing the schema. So Ryan talked about it. It's called DDL, just creating table types, just the structure. And the second tab called GraphQL will be to interact with data. So we just created a new table called reference list. We will put data in it. And then we will come back to the first tab, create another table, and go back and insert data in the new table. And you will see we will move from one to another.
Yep. And this tab, the second tab, is emulates more what the actual app will do. This is the endpoint that the app uses and the types of commands that the app will use as well. All right, so we are going to create another mutation because we're inserting data. So it's a mutation command. And I'm going to go ahead and copy this out of the GitHub repo. So I'm in, oh, sorry. One thing I had to do, I had not finished putting in my token. So we're in the second tab. We need to give it the token again because it's a separate endpoint, which I copied over already. Oh boy. All right, so
you
we're gonna.
Do have your window still open.
I do. So far, it's still there. Just highlight populate me. Gonna put in my token. But we need to do one more thing. And I'm gonna make my window bigger a little bit because the default endpoint that the playground uses is not correct. The default endpoint that it uses is the system endpoint. We actually want our key space that we created. So we need to replace system with Netflix. And when we change that, and I'm editing this URL up here in the playground. I'm not editing the URL in my browser. It's this URL in the playground. You just need to replace the part that says system with our key space name, which is Netflix. Hello, Kesar. Welcome back.
Hello, hello. Nice to see you.
And once you change that URL, that endpoint, all the errors should go away. Those are the two things that we need to do. So token and the endpoint URL. All right, so now we can do our data insert. So I'm on step 4C, and I'm just gonna copy this over to the playground so it's a little easier to see.
Are we moving too fast? Are you able to follow again? Just some thumb up to tell us if we are moving too fast or not.
Yeah, feel free to let us know to slow down if you need time to catch up or need any clarification. Happy to slow down. All right, we got some thumbs up. Not too fast for you, Cedric?
No, I think I'm able to follow. Yeah.
Awesome. All right, Iqbal says good pace. Perfect.
Nice.
Okay, so we're defining a new mutation. We're calling this mutation insert genres. And we have a few separate mutations that we're actually going to do. We're bundling a bunch of different mutations in this single API call. And so we're calling this one, the name is action. And we have a command here. Now this command is actually generated. You can see that we have our table name right here. So this is actually a generated command, and it just appends the command insert, right? Because we're inserting data to the name of the table. So insert reference list is going to insert data into the table reference list. And then we're going to define the data. So in our values clause, we have the label, which is one of our columns. We're going to label it genre, and the value, which is the other column, we're labeling it action. And we're going to do that for each one of these mutations that we have bundled here. And then we are actually requesting a return from this mutation call, and it's just going to give us the value back to us. So it'll be basically confirm, action has been created. What's the other one? Anime has been created. Award-winning. All these genres have been added. So hopefully that makes sense. Again, this is a generated command. It just appends the command insert to whatever table you want. So, you know, if we had a table called genres, if we just called it genres, it would be insert genres. So it's pretty clever how it works. So I'm going to go ahead and click the big play button. And we should see it returns the values that we requested: action, anime, award-winning. So it's basically confirming all of these genres have been inserted into our table.
And so this table reference list is used in our application to list all the genre. If you remember the homepage of Netflix, here you see, you know, adventure, action, French, comedy, cult. This is all the genre we will have. And so what we will do next is create the table movies.
Yep. Yeah, Jackie South says that when you change to the correct endpoint, it says authentication required. You need to open the HTTP headers again for this tab and enter your token again. So you have to do that twice, one for each tab. Hopefully that's clear. Okay, so now we've inserted data into our reference list. Let's go ahead and do a test query. I'm going to go ahead and get rid of that mutation. A test query to get those genres, right? So in our final app, we're going to want to query the database and get all of the genres that we have. And so I'm going to go ahead and paste that in here. And so now, because we're not actually inserting data, we're just querying data. The command is query for this. In this case, we're just retrieving the data. We're naming this query get all genre, and we're defining what table we are querying, reference list in this case, and the values that we're requesting, right? So we don't want all of the data. Like Cedric said, GraphQL allows us to specifically retrieve the data that we want rather than just getting everything. So we are requesting the value and where the label is genre. So wherever the label column has genre, which in this case is all of the data, we want to retrieve the value, which would be the name of the genre, right? So if I go ahead and execute this, you'll see we have the name of our table, reference list, all of our values, and we just have value, action, value, anime. We don't have the label genre for each one. We just have the value. So that reduces the amount of bandwidth that we use. In this case, not much, but in other cases, it would be a lot. So this is a good representation of the types of queries that we can do and what we will do in the front end. Okay, so moving on to step 6, we are going to create another table. This is for our movies. And because we're creating a table, we need to go back to the first tab, the GraphQL schema tab. So I'm moving back to the first tab. We shouldn't have to re-enter any of the token or anything because it should be saved. I'm going to go ahead and get rid of this mutation that I had from the last table. And I'm going to copy over this new mutation, which is another create table command. So it should be very familiar. We're naming this, this mutation movies by genre. We're creating a table in our keyspace Netflix. We're naming the table movies by genre. And if not exists equals true, so it's not going to create it if it already exists. And we're defining some columns here. Now I'll talk a little bit more about what the partition and clustering does here. So you'll notice that we named the table movies by genre. And what that means is that we're storing data for movies and we're partitioning by genre. And what a partition is because we are working in a distributed system, we have a 3-node cluster in this case, we want to distribute our data around that cluster so that we can maintain performance and availability in case one of those nodes goes down. So in this case, the value that we're using to determine where the data goes is genre, the value of genre. And that's called our partition key. That's how we're partitioning this up. So when we define a partition key, which all tables need in Cassandra, that is what we're doing. We're basically telling the database, this is how you're going to distribute that data around the cluster. And in this case, we're just using the genre. Clustering keys is how we actually define the uniqueness of each row in tandem with the partition key. So the partition key plus the clustering keys should define a unique row. So in this case, genre, year, and title should define one unique movie, right? So there should be an action movie with a title Inception, or title Inception, released in the year 2010. I think that's right, 2010. That is going to be one unique movie. There could be another movie released in 2010 called Inception, but it might be a drama, right? So that would be another unique movie. Obviously there wasn't, but another thing that we can do with clustering keys is this order command, which I talked about a little bit in the last table that we created. This actually allows us to store this data on disk in a certain order, so that we don't have to do an order by command when we retrieve it. It will be retrieved in the order that we want because we defined it when we created the table. That just allows things to be quicker and more performant, because ordering stuff on write is much faster than ordering stuff on read. And then the rest of these are the rest of the columns, right? So we have synopsis, duration, thumbnail, and their data types. These are just the remainder of the columns that are not partition keys or clustering keys. Harmesh asks, will the replication key
Yes.
also have to be the same as the partition key?
Yeah.
Not sure how to answer that. The replication is by default with your cluster is going to be replicated on 3 nodes, which is all the nodes you have currently.
Yeah.
Yeah.
So very good question from David Lambert. So yeah, you can have only one partition key per table. So you basically build your table based on the query you need. And if you have multiple queries on the very same data, well, you will create multiple tables, even if the data is replicated. This is a trade-off to work with a NoSQL distributed system. Just store the data in the way it should be retrieved, because storage is cheap. This kind of database fit millions and millions on record. We have not chosen the use case like that. If you look at our YouTube channel, you will see a 1-hour presentation from the technical leader of Netflix explaining why at Netflix 98% of the streaming data is stored on Cassandra. So it's nice for us advocating for Cassandra to have such a strong use case. But there are some trade-offs. You really need to shape your table the best way to retrieve the data.
Yeah. So you do end up repeating data. It's a denormalized structure. It's not a normalized structure. But it really helps that performance and
oh yeah,
and stuff. So we go into much more detail on this side of things in our introduction to Cassandra
and
workshop.
I think it will be next week, if I'm not mistaken.
Oh, are we doing that? So we will be doing that live next week. We do have a crash
Intro
course.
To Cassandra is done next week live.
Awesome.
So datastacks.com/workshops just to register. And also, if you have not done it, you can subscribe to the YouTube channel, because we post the video that will be released a few days before.
Okay, so I'm going to go ahead and press the play button to execute this mutation, and we now have our movies by genre is true, meaning that table has been created. Perfect. So now let's insert some values into this table. So I'm going back to the GraphQL tab, the second tab, because we're going to insert some data. I'm going to go ahead and clear this. I'm going to copy this mutation out of GitHub and just paste it here so we can take a look at it closer. All right. So again, we're going to define a mutation that's going to be a bundle of a few different mutations. And the mutation as a whole is called insert movies. And then each mutation is going to have a name. So we're naming it, the first one is inception. And again, we're using this generated command, insert table name, right? So insert movies by genre is going to be the command that we use. And we're going to give the values for the columns. So genre is the sci-fi, year is 2010, title is inception, synopsis. So all of our data is in here. And then we're requesting the title back. So when we execute this mutation, it's going to send back the titles confirming inception has been inserted, basically. And we're going to do that for all 4 of these movies here. So go ahead and execute it, and we can see that we are receiving the title back from each of these, telling us that it has successfully been inserted. Okay. So let's go ahead and, I'm moving to step 8, by the way. We're going to do a sample query and query this, this new table that we've created. All right, so we're creating a query. So we're calling it get movie action. We're querying the table movies by genre. We're giving it the value genre sci-fi. So we're specifically looking for the sci-fi genre. And then we're going to order the results by year descending. Now, we defined the clustering key year in order descending, so we probably don't actually need to do that. Am I correct in assuming that, Cedric?
Say it again.
We've defined the table with a clustering key of year ordered descending.
Yes.
So this query command probably doesn't need this order by year descending, does it?
No, it does not. It does not. When you provide some ordering clause, when you create the table, the data is ordered like that on disk. So when you select, what you will retrieve is already ordered. It's a way to speed up, again, the query. By the way, at the end of the workshop, when you will see all the movies on screen, you will see they are not ordered by alphabetical order. This is because year come before title when we created the table. It's not the best maybe, but if we have switched year and title, now on screen everything will be on alphabetical order.
Yeah. And then we are specifying the values that we want returned. So we want the year, title, duration, synopsis, and thumbnail. This is pretty much all the data that I think the table has, but because of how GraphQL works, we could specify just one of these things that we want back, and that will reduce the amount of bandwidth that it uses. I'm going to go ahead and execute this, and you can see that we are getting all of these movies that we've entered. These are all the sci-fi movies, and we get all the data that we requested. How about the future data we insert later? Yes. So anytime you insert data, because that clustering key is defined year descending, it will write it on disk in the correct order. Yep. Yasmin asks, when you say it is generated automatically, from what is it generated automatically? By which command? So because Cedric talked about, and maybe Cedric, you can talk about this more specifically, but you talked about how GraphQL has the discoverability aspect of it. Would you say that's related?
I'm not sure about this question, to be honest. I was thinking, when did we say it's generated automatically? Oh, yes, when you create a table using the mutation we just defined together, we created a table movie. Then the schema, the GraphQL schema, the one that is exposed to client to see what are the functions available, it will change automatically. It will be updated. And then you will have new function like insert or delete in the table we just created. So Ryan just showing the schema right now. So he went totally on the right part of the screen, click on the schema, and here you can see that now we do have new mutation, insert into a movie, insert into reference list. This is why what is generated automatically. Create a table, and we are doing everything you need to be able to interact with that table.
Yeah, so the API has knowledge of what your schema looks like, and that's how it generates the commands.
Okay, and I finally have the link for Seravi about, the Netflix presentation, I promise. It's now in the chat.
Awesome. All right, so
okay, good.
Now we currently only have 4 entries into our table, but eventually we're going to have hundreds, if not thousands, of entries in our table. And if we are requesting all of this data, even within a certain genre, we might have a lot of data, and we want to limit how much data we're retrieving. And so for that, we use paging so that we can retrieve only a certain number of entries at a time. And to do that, I'm going to go ahead and copy this new query over. All we do is we add an options section to our query, and we give the page size the number of entries that we want to retrieve in any given query. And then on the return, we request the page state, and the page state is generated, a generated value that kind of is a bookmark, if you will, in where in the page we are, and we can give that page state back on a new request, and it will give us the subsequent page. So to illustrate this, I'm just going to go ahead and execute this, and you can see that instead of retrieving all of the entries, we are only retrieving 2. We have Prometheus and Inception, because we defined our page size as 2, and it's sending us back this page state right here, this jumble of characters and craziness. If I go ahead and copy this page state, pardon me, we can actually I'm going to go ahead and copy this new query. So now in the options, I'm also defining a page state value. And if I give this request, this new query, the page state that I received in my last query, right here, and then I execute it, I'll get the next page of values, right? So in this case, Aliens and Blade Runner. And then it'll give us a new page state that we can then use to get the next page, right? And so we can use that to limit how much data that we're retrieving at any given time, but make sure that we're getting all of the data that we want subsequently. And so we can use this for, in our front end, we're going to use this for our infinite scrolling, right? So it's only going to load a certain number of genres until we scroll to the bottom, and then it'll load the next page of genres. And also in each given genre, it's only going to load a certain number of movies until we click the next button, and it'll load the next set of movies. So we're going to be using this paging in the front end as well. How do you get previous page? That's a good question. How will the page state update in the front end? You will have to manage that. So we're requesting the page state to be returned to us. We'll save that in a variable, and then we'll provide that in the next request.
And the previous state, I'm afraid you need to to save as well the page state in your React Redux part, because it's only moving forward. In the page state, you have the request time when you access the data, the offset when you should start, and how many items you should retrieve. Everything you need to request the next page, and it's built page after page. So to get back the previous, just provide the previous page state.
Yep. And these page states are, these values are deterministic. So if I execute this again, this page state is the same. So that's, do you disagree, Cedric?
No, I'm
Okay.
just got a question.
Okay,
No, that's
sounds good.
exactly that. Yeah, it's page state is a very long string, and encoded in this string, you have the request, what it was. You have at what time had this been requested. So in between, if you have new record inserted in the database, you won't get them. Okay, it's recorded at a certain point of time, and how many points you need to retrieve. And it's not like it is overwritten each time. It just, for each query, as a response, you get a specific page state. And this is your job at the front-end level to save them if you want to get them later.
Yeah. All right. So that is the basics of GraphQL. We've now used GraphQL to create tables, to insert data, to query data using the paging feature. It's quite a lot. Hopefully everyone followed pretty well. Give us a thumbs up if you feel comfortable with what we've gone over so far. If you have any questions specifically about anything that we've talked about, let us know. The next thing that we want to do is we're going to load a bunch of data now. And we're not going to be using GraphQL Playground to do this. We're going to be using the bulk data loader in Astra. And that is our next step. So moving to step 9. I'm gonna sneeze again. You see this big green button to download dataset. So if you right click this button and click on Save Link As, it should open a dialog.
Yes, because we are about to enter 6,000 movies.
Yep.
And the GraphQL Playground may be good, but for 6,000, we have better.
Yeah. It is a playground after all. So in some operating systems, in some browsers, it will not automatically append the .csv when you download this. Make sure you do that. Otherwise, it'll get confused. I think I already have one, but I'm going to save over it. So make sure if it does not include the .csv, make sure you include that because it is a CSV. Go ahead and save. I'm going to replace mine. Download that CSV. And then in your Astra account, the window closed. My token is gone. All right, so I have to refresh and sign back in. In your Astra account, if you click into your database, so I'm going to workshops again, up at the top, you should see this load data button. Top right, there should be a load data button. Go ahead and click that. And then upload your movies by genre CSV. Then click on next. And it will give you a preview of some of the data that's included in here. It's obviously not going to be comprehensive. The table name should be fine. Because the CSV is named movies by genre, the table name should also be called that. If for some reason it has a different name, make sure that you name the table name movies by genre with underscores in between the words. That will determine which table it enters into. And then we need to select the partition key. And remember that we defined the partition key when we created the table as genre. So we'll select that. We don't need to do anything else. We don't need to select the clustering columns. All of that will be managed automatically. So I am now moving on to step 9E. I'm going to click next. And the target database is workshops, which is good. Target key space, select Netflix, which should be the only key space you have unless you have already created a workshops database and you have multiple key spaces. Just make sure you select Netflix. Too fast. Okay. Sorry. I'll run through it again. I'm going to click next. So it's going to start uploading that data. So in your workshops dashboard on Astra, go to load data at the top right. Click that. You can drag and drop that CSV that you downloaded here, or you can click in here and navigate to it. Like that. And then you can click next. It will give you a preview. The table name should be defined by the name of the file, which should be good. If not, make sure it is movies by genre with underscores. And then you can just scroll down to partition keys and select genre for your partition key, because that is what we defined when we created the table. You don't need to do anything else. You just need to select the partition key. The clustering columns are fine. And then click next and make sure you select your Netflix key space. The database should be fine because you already selected the database before you went to this tool. And then you select the key space. And then you can click next to upload the data. Simon asks, how do you download the web page? Do you mean how do you download the CSV? So in the GitHub repo, in step 9, there's the big download dataset button. If you right click it and click on save link as, you'll be able to save the file. Now, my OS on Mac and Google Chrome, for some reason, it does not automatically append the .csv. So I have to add that manually. If you forgot to do this and just download the file, you can add the extension manually on your computer, or you can just download it again if you want. So make sure you do .csv when you download it, and then you can use that to upload.
Nice.
Cool. All right, so now it'll take a little bit. You'll get an email status of when Astra has started and when it has completed. It'll take a little bit to do that. I'm not sure how long. But with that, while we're waiting for that, do you have some slides, Cedric?
Just yes.
Yes.
Maybe just one. So you will get a first email when your file will start to be processed, and you will get another email telling you that all the data has been imported. And with that, you are done with the database. The database is ready, your 2 tables, all the data is there, and we can move to the code. So the code is written in JavaScript, okay? React for the front end. You don't have to code yourself. And in 2 hours, to be honest, it's pretty hard to ask you really to code. So the code is ready. And what we will do, we will open an IDE in the cloud, edit the code, because you need to set up the code to connect to the database, and then we will be able to start. Okay. You have seen the final app running in the cloud because we are using a service called Netlify. Netlify will host all the code for you. That means you can have the full app running there for free. You are not charged either for the database or for the web server to run. And I found it pretty cool, okay? But before deploying to Netlify, and this is what we will ask you maybe as a homework if we don't have time today, we will use something called Gitpod. It's an IDE in the cloud. It's VS Code, okay? VS Code in a browser. You don't have to install, and you will see there all the code you need. And also you have the tools needed to work with JavaScript. So Node, NPM to download and build. And so in Gitpod, you will see we will build the application, run the application, and we will do everything to connect to Astra. And inside Gitpod, we will start the real application. And based on how much time we will left, we could just deploy on Netlify or not. It's all described in the README. And with that, I think it was one of the latest slide I had for you today. Now it's all about you coding.
All right. Cool. So I am now moving to part 2 in our GitHub repo. And the first thing we're going to do is launch the Gitpod IDE. And you can click on this button right here to launch. I'm going to open it in a new tab. And I'm going to move that tab over to my big window. And this will take just a little bit to spin up. So what Gitpod is doing, it's a cloud-based IDE based on VS Code. And it allows us to define certain environments. So what it's going to do right away is install all of these dependencies that we have, to install the correct version of Node, install the correct version of NPM, all these different things that we have defined. So it makes it really easy to get a environment up and running really quickly. While it's doing that, though, we can take a look at the code and kind of walk through it while we're waiting for it to fully set up. So if you take a look at the functions directory, actually, I'm going to make this window bigger.
Yes, I think at least for the code.
Let me know if it needs to be bigger. Hopefully that's good.
Yeah, just open the function, and see. I think, Gitpod needs to be.
Yep. There it is.
Be good.
Okay, so we're going to be using serverless functions. Instead of trying to craft our own backend infrastructure, Netlify actually allows us to use serverless functions where we can define very simple functions. It will dynamically create endpoints for those functions that we can then call from our front end, and then it'll execute those functions on the server and pass us back the data. So instead of standing up our own like Express server or whatever, we can rely on Netlify to do all that for us, which is really, really useful. And the way that we do that is in our root directory, we're going to create a folder called functions, and you can see that here. I'm going to drop that down. And any file that's in here is what Netlify is going to recognize as a serverless function. It's going to create a unique endpoint for each one of these files. So I'm going to go ahead and open up Git genres. And you can also see I have the code pasted in GitHub as well. So you can see that in there as well. But I'll walk through it in the, oops. It opened the README. I'll walk through it in Gitpod. So it's pretty simple. It's there's a standard format for the serverless functions, the exports.handler. We're going to define an async function, and it's going to be watching for an event. And it's going to parse the event body. So basically, this is the request that we're hitting this endpoint with. And it's going to create a query, and you'll recognize this query as one of the queries that we've defined. Oops, go away, dictionary. One of the queries that we created in our GraphQL playground, right? We have our reference list, right? The table that contains all the genres. We're looking for the values where the label is genre. In our options, we have our page size and page state so that we can do paging. And we are looking in the body of our request for those values. So from the front end, we can determine what is our page size, how many entries do we want per request, and what is the page state? Because when we retrieve back that page state, we're going to save it as a variable and give it back when we make a new request. So it's going to be looking for those values there, and it's just going to return the value of our genres, and also, importantly, the new page state. So this is the query that we've crafted. The URL is going to be a GraphQL endpoint, and I'll get into what this is referencing. This is going to reference an environment variable, which is a kind of a secure way to store sensitive information, which an endpoint is. And then it's going to do a fetch call, right? This is a built-in JavaScript fetch call. It's just a post, and we're going to append our application token to authenticate our request. And then the body is just going to be our query that we've defined already. That is our response. it's going to attempt that query, and if it's successful, it'll give us a status 200. It will send back the response body, which will be all the values. And then if it errors, it will give a 500 and send back an error message.
So this is our client, in a way, interacting with the GraphQL API we just discussed before.
Yep. Yeah, this is kind of our back end, if you will. It is a simple serverless function, but this is our back end communicating with our database through that GraphQL API.
Yep.
And the get movies is very similar. We are hard coding the page size to 6 in this case, but we are still looking for the page state. Everything else should be pretty much the same.
Yes, so question post is not a create. So in the case of netlify function, you will define a function, okay, do something, and the do something will be available both on post and get. And it is just the speciality of the serverless function we are using here.
Okay, so I've kind of talked through this already. Perfect. So now I'm moving to step 3. You can see that our environment has fully set up. Our terminal is done freaking out. But let's take a look real quick at the main source code for the front end. So under src, under our source directory, let's open the app.js. So this is our main app file. And you will see that this is where we're going to be fetching all our genres. This is the point where we're going to be doing that request for the genres. We have a const page size called for. So this is where we define how many genres we want to load each time we request, right? Our page size. So this is where we can change that. We have our page state variable defined here, so that we can use that in our request, and we can also set that to the new value. And we have a few other state variables for our genres. You know what genres we have, so that we can then use those values to retrieve the movies. But this is the important part. This is our fetch statement. So we have a quick check to see if it is fetching. That's just to make sure that we're not fetching multiple times, which has happened, which is why we added it. Our response, so we are fetching from this endpoint. So this is the endpoint that Netlify generates based on that that file. So we have our, open this again. We have our get genres serverless function here. It's going to generate an endpoint at .netlify/functions/get genres. So this is the endpoint that Netlify generates that we can request from. The method is post, and the body is just going to be we want to give it our page state and our page size, right? Everything else is handled by the serverless function. It's just requesting the size of the page that we want, right? Because we determined that that's going to be determined by the front end, and the current page state, which initially our page state is null, right? Because the first one is just going to be the first page. And then that page state will be overwritten. So we have our response body. This is what we're getting back. And then we're setting the page state to response body.data.referencelist.page state. So this is the path to that new state that we're getting back. So now we're storing the new state that we can then give it for the next page. And then we're getting the genres. And so we're setting our genres variable to the values that we're getting back. Now, note that we're concatenating this to the current value of genres. So we're not replacing all the genres in that variable. We're just adding more genres to the list. Because when we want to do our infinite scroll, we don't want to just replace the currently populated genres. We want to actually build that list as we scroll.
Oh, I think I did not show the infinite scrolling. So as soon as you do have the app running, you can demo this infinite scroll. We just load the first genre, and by scrolling, we just adding in the list to give the impression of this infinite scrolling.
Yep. Yeah. So the way we're using our genres variable, right, is we are actually mapping the array of values that we have to a component, a subcomponent called section. We're giving it the genre value, so action, anime, whatnot, as the key just for the map value. And then our genre is also that genre value. So let's go to the section component. So I'm going to drop down components here and go to section. And this should look very familiar. Again, this is where we're requesting movies. So our generated netlify endpoint is going to be .netlify /functions, /get movies for that serverless function. And we're providing it the genre and the page state. We've hard-coded a page size of 6. So we don't need to provide that, but we do need to provide the genre that we're requesting so that we get the specific genre that we want. And then, the response is our values, the movie's values, and then the page state, because we want to make sure that we can provide that new page state for the next page. All right, and then we're doing the same type of thing. We're mapping the values there to a card, which is just the information, or just the individual movie component. All right, so with that, does that make sense to everyone? Give us a thumbs up if that makes sense, or if you have any questions specifically about that stuff. All of this is also written in the GitHub, so if I moved too quickly, you can go ahead and read through that if you prefer to read it as well. But while I wait for any questions, let's move on. I'm on step 4. We're going to install the Netlify CLI, and what this does is provide a development environment that replicates what Netlify would do in the real world if we were to actually host this to production. So this allows us to run our app as if it's running in the Netlify environment on our local machine, and in this case in Gitpod. So I'm going to go ahead and install the Netlify CLI. I'm just going to copy that command out of GitHub. It will ask you to allow copying, pasting. So if you are copy pasting, make sure you click allow. Willie asks, what are the actions needed if we want to run this locally? If you want to run it locally on your machine, you can pull the code from GitHub and just run it through VS Code. Make sure that you're running the correct versions of Node and NPM. I believe we're on Node
16.
16. Node 16?
16.13. You can go to .gitpod.yaml to be sure, but yeah, I think it's 16.13.
Yep, 16.13, and then the NPM version is 8.1.4. So if you are running those versions, hopefully it works on other ones as well, but we know it works on these. So I don't think that we have any weird commands. Some of our other workshops have some commands that require certain versions of Node and up. So just if you want to work locally, feel free to.
I think it's clone the repo and start at step 4, like npm install. You really need to have npm, and with npm and Node, you're good to go. You will do npm install, npm build, you will install Netlify CLI and be able to execute everything else. So really clone the repo, but have Node and npm install.
Willie clarifies that the question was about running the code without Netlify. So if you wanted to run without Netlify, you would not be able to rely on serverless functions necessarily. You would have to create a backend application, like an Express server or something, and define your own endpoints and your own logic there that you can then call from your front end. So a lot more work.
The idea is you need that backend in a way. So here it's done with serverless function. If serverless function is not provided, Netlify is not there, you still need something else. Express is really the go-to when it comes to exposing REST services in Node.js. You might think, why cannot I just plug the React app to the GraphQL backend in the database? It should be easy to do, right? There is nothing preventing you to do so. Well, the issue then is you would have the API token, your authentication key store in your front end. And if it's stored in your front end, it's downloaded by your client and it's visible for your client. And now your client can see the API token you use to interact with the database. So this backend is a way as well to secure your credentials.
Yeah. Everything in the front end should be assumed that it is readable, because it is. All right. So I am moving now to step 5. I have installed the Netlify CLI. We are going to need our application token for this step. I still have my playground open, so I'm going to copy it out of here so I don't have to open that CSV. But if you need to open that CSV that you downloaded, go ahead. If you did not download a CSV and don't have the tab open, you can generate a new token just fine. So I have that copied, that token copied. So we need to create a .env file. This is where we're going to store our environment variables. We have a sample file here, .env.sample. So this is just a sample. This is kind of specifying the kind of what it will look like. Don't edit this file. Create a new file. I'm going to do it through the GUI here. I'm going to right click and click new file. Name it .env. And in this file, I'm going to go ahead and copy this structure out of the step 6 now. I'm in step 6. Copy this into the new file. So we have our AstraDB application token and our Astra GraphQL endpoint. These are the two values that we need. Now we need to replace the parts that say replace me. And of course I copied over the token. So I'm going to copy my token out of my playground. And I'm going to replace the token part with my token. And now I need my GraphQL endpoint. So in your dashboard, in your Astra dashboard, hopefully you guys didn't time out. I almost did. If you click into your database, go up to the Connect tab, click on the GraphQL API, right? Because that's what we're using. And then if you scroll down to number 4, right before create a table, you'll see that here's the endpoint. This is the endpoint that we need right here. You'll see that it ends in Netflix, right? This is actually the same endpoint that we edited in the second tab of GraphQL Playground. So if you still have that window open, you can actually copy it. If you're in the second tab, you can actually copy this URL. This is the same one. And I'm going to replace the GraphQL endpoint in my .env file with this URL, like that. All right, and then autosave should be on, so I'm just sanity check, save it. Do I need to zoom in one more time? Okay, so now, just to make sure that all the packages are installed, we're going to run npm install. This will make sure that all the dependencies are installed. This should have been run when Gitpod opened up, but just to make sure, it shouldn't take very long if nothing needs to be changed.
Yeah, the first time you run npm install, you need to download quite a lot of dependencies. Yeah. It could take a minute easily.
Roughly 50% of the internet. That's how much you have to download.
The other 50% is for Maven, the Java package manager.
That's fine. All right, and now we're actually ready to launch our app, and we're going to run it using this command, netlify dev. This will use the Netlify CLI to run our app rather than using npm start or whatnot. Netlify dev will run it in that environment. How do you open the .env file? It does not open. So you need to create your own .env file, and you can do so in the GUI here in your IDE. You can just right click on this on your Explorer window and click on New File. You can also, if you're more comfortable in the terminal, you can type touch.env. That will create the file, and it should just open it in this window here. Yeah.
Yep.
All right, so when you run Netlify dev, it will open your app in a simple browser. There's an icon up in the top right here that I'm highlighting right now. If you click that, it'll open that in a new tab so you can see that it's bigger. And this is the app now that is running through Gitpod. And you can see all of our movies, all of our 6,000 movies are here.
Yeah, but it's not loaded in one way. 6,000 would be way too much for your mobile app or web app. And this is why it's paged. So paged by the genre. So as you can see now on Ryan's screen, we only have 4 genre and on each 6. But if Ryan put his mouse over, below children and family, and you can do the same at home, you will see that more and more genre will appear in the UI.
Yeah, so the way that the app is coded is it's detecting the mouse, where the mouse is. So I'm not loading the next page yet until my mouse goes below the cult genre. And now you can see the next page loads. So it's waiting for that mouse enter event. And then it'll load the next ones.
Yeah. And if you look at the teasers, okay, they are all looking the same. I think we do have 30 teasers that we shuffled in the 6,000 movies. Okay, it was not that easy to find 6,000 videos. Maybe next time we run the workshop, we would have find a way to have just the covers of each movie. But until then, hey, you do have 30 and it's shuffled. So don't be surprised if you see the same and again and again. The title of the movies are all different.
Yeah, and as you can see, we're also paging the genres themselves. So we only have 6 action movies, but if I click this right button, you'll see that they all change to the next 6. So we're doing the next page, and I can do that again to the next page. And they are all different. The thumbnails are repeated because we don't have 6,000 different thumbnails. But that is our app now running. So if you have gotten this far, give us a thumbs up and give yourself a pat on the back because you have successfully.
And congratulations!
Yeah, congratulations.
It's a full stack app.
Awesome. So if there are, let us know if you have any questions. We can address those. With that, a few things to talk about. We have some extra resources in the GitHub repo. There is a video tutorial with a creator friend of ours, Anya Kubau, that goes over more of the React side of things. So if you're interested in how the front end was developed, that video, it's like a 2-hour video, is a great resource to go over that part of things. And we also have the instructions. If you want to deploy this Netflix clone to Netlify and actually host it on your own URL, you can do that. And these are the steps for that. It will require a Netlify account, which is free. It will also require you to, if you use this button Netlify, it will clone the repo to your own personal GitHub repo. And then you should run through the instructions from your repo. You want to make sure that you're working out of your own repo and not our repo, because there's some things to consider about that.
So we told you it's cool because your code is deployed on Netlify for free and running for free, which is also cool. As soon as you have deployed Netlify is linked to your code. That means each time you do a commit in the GitHub repo, the code is redeployed. And that's it's a bit of magic because as soon as everything is in place, oh, I'm not happy with that stuff in production. Okay, I'm going to GitHub, edit stuff, commit, and boom, the app is updating 2 minutes later.
Yeah, Kaiser says app shows, but all data not there. DB file did not load. Yeah, if you did not get an email confirming that the bulk load was done, it might be still working on it or stuck or something. You can try uploading the CSV again and see if that helps. But that really sounds like it didn't load the data.
Yeah, and if it's not working, you can reach out to us on Discord, and we will see. We can check your database if everything is okay. You do have the table and see what's going on.
All right. Well, with that, I think we have a game to do, don't we?
Yeah, I mean, we take our time. You were able to follow that. That's great. It's now time to play a game, right?
It is time for the game. All
Woohoo!
right. So if you hopefully you still have Menti up in your on your phone or in a separate tab or whatnot.
And if
If
not, I'm
not,
sharing the link again.
yes.
Oh, so question about the latency. So you pick your database close to you. You know, you pick a region, so you make sure to have the data as close as possible to you. So if you invoke just a GraphQL piece, you will see something like 20 millisecond-ish response time for the round trip. On top of it, you put some React and JavaScript code. So if the JavaScript is hosted in your machine, this is no more latency added. If you deploy in Netlify, make sure that when you deploy in Netlify, settings in your seat, you deploy your app in the same region as your database. Otherwise, well, you need to go to the website, I don't know, in the USA and look at the data in EMEA. That will not be very performant. So in the Netlify settings, when you deploy, make sure that you host your app in the proper data center, close to your data. I mean, you know, at least the region.
Yep. All right. Looks like we have a bunch of people in Menti. So we're going to go ahead and do the game. Now, I think Cedric mentioned
Wait
this
for
before.
me, wait for me.
If to get the most points, you need to not only get the correct answer, but you need to answer quickly. So make sure that you're watching your phone or the tab that you have Menti open in, because that will certainly update sooner than watching the stream. So make sure you watch your phone and answer as quickly as possible. All right.
So it's a game, but if you answer fast, you get more points, and look at your phone.
Yes. First question, what is AstraDB? It is a local in-memory database. It is a database as a service based on Apache Cassandra, or it's a gateway to the stars. All right. Yes, most people got that correct. It is a database as a service based on Apache Cassandra. Let's see what the leaderboard. Kaiser cannot see choices. Uh-oh. That's not good. Try refreshing.
Yeah, wow. Yeah, that's weird.
Cedric the presenter. Is that you?
I told you I was playing.
Oh boy. Oh boy. All right. Well, Shubham and Templar are second and third, but it's pretty close. All right. Second question. In GraphQL, which operations do you use to edit data? Query, edit, mutation, writes, or pencil?
Pencil is good, right? You can you know erase and rewrite.
Yeah, very useful. Unless the eraser sucks. I hate that.
Oh, yeah.
All right. Yes, most of you got the correct. Mutation is the operation for editing data with GraphQL. Let's take a look at the leaderboard. All right, the fastest. Kwangun is the fastest. Congratulations, moves up to the first place. Amit is in second, and David is in third. And just so you know, the top three winners will get prizes. So you don't need to get first, but you do need to get top three. All right, question 3.
Yeah, go fast, but be correct.
All right, what can't you do with GraphQL? Now, you might need to do a little bit of inference with this one. We didn't specifically talk about it, but you can maybe rule it out. So auto discoverability, schemaless, federation, and response customization. So what can you not
This
do?
one is a bit tricky, right?
It is tricky.
Maybe,
It is
maybe
tricky.
not. I don't know.
All right. So the correct answer is schemaless. You actually need a schema for GraphQL. So you cannot do schemaless.
Yeah, you always start with creating the entity.
Mm-hmm. All right, let's see what the leaderboard says. All right, Maryam is the fastest. Brings them up to first place. But don't fret. The game can change really quickly. We have how many questions left? Question 4. So we have 3 questions left. What are the terms used for paging? Paging size and paging cursor, page size and page state, page number, or book title and bookmark. All right. Yes, page size and page state is correct.
Yeah, nice.
Take a look at the leaderboard. All right, Miriam's still in first place, but Kwanggun Choi is in pretty close second, and Amit Kathak is in third. Question 5. What is Netlify? Is it a platform to build and deploy web apps, a Java application server, a code review tool, or software to calculate your tax rate? All right, yes, it is a platform to build and deploy web apps. Awesome. So who was fastest? It's like Willie. Willie was fastest. Top 3 has changed a little bit. Let's get to our last question.
Let's see.
Final question, final chance.
Woohoo!
What is the main benefit of using serverless functions? I only need one function to retrieve my data. No backend infrastructure needed. Or none, serverless functions are only for local development. All right, so it's kind of 50-50, but the main benefit is no backend infrastructure needed. You do need different functions for different functions, and it is for more than just local development. So let's take a look and see how this changes things. Ramesh was the fastest this time. David is in first place. Congratulations, David. And Kishitij, I don't know how to pronounce that, sorry, is in second. And Kwangjun Choi is in third. Congratulations. If you are in the top 3, make sure you take a screenshot of this page or this screen on your phone or on your browser. And you'll use that screenshot to send to jack.fryer@datastacks.com to get your swag.
Let me drop the email in the YouTube chat right now. And do not forget your screenshot.
Yep.
And also, we make sure that people win only once to ship swag to most people, as many people as possible.
Yep. So I'll go back to this page just so if you didn't get the screenshot, you can get it. We have one final question, obviously not for the game, but we do want to know what should we improve for next session? Is there anything that you would like to see us do differently? We're always trying to improve our workshops, so we really value your feedback. And we also have a channel on our Discord for workshop feedback if you would like to put it there as well. All right. So just as some closing remarks, jack.fryer@datastacks.com is the email that you can send your screenshot to claim your prize. And Jack will reach out to you for more information on how to get that swag sent to you. If you are interested in getting a badge for this workshop, there is instructions in the GitHub repo for the homework.
Yep.
It's pretty easy. You're going to import a movie of your choice into the DP, into the database with GraphQL, and you can emulate step 7 of part 1, and then show a screenshot of your Netflix clone running in Gitpod, or if you decided to deploy it to Netlify, you can get a screenshot of that. Make sure you show your added movie as well. And an optional, we recommend watching Anya's video if you're more interested in the React side of things. It is a very good video to watch, and would be a great way to learn that stuff.
And she is really building the application in front of you. So that's cool to see. Live coding in a way.
So workshops, we do workshops every single week. You can go to datastacks.com/workshops to see what workshops are coming up. And that keeps updating every week. And we also have a backlog of all the workshops that we've done. We do record them and host them, and we do regularly repeat them live. So go ahead and subscribe to our YouTube channel if you want to see more of that.
Please.
And if you want to continue your learning, we have a few other resources. Academy.datastacks.com is a place that you can go to learn more about Apache Cassandra. We also have learning paths for our certification, Cassandra certification. You can find that there. There's also datastacks.com/dev, which has a few courses as well, talking about Cassandra and Astra, as well as community.datastacks.com, which is kind of like Stack Overflow, where you can ask questions specifically about Cassandra or anything that we do here at DataStacks. And of course, the YouTube channel. So you can subscribe there if you want to see more videos and be notified of when we go live and whatnot. It's a great place to do it. So we are actually offering free vouchers for the certification, Cassandra certification.
Free.
A link there. Yep. So you can use this link. It'll be in the chat as well. That you can claim these vouchers. They're valid for 3 months and 2 attempts. And again, you can go to academy.datastacks.com to go through all the learning courses needed to complete those certifications. And finally, one last plug for our Discord community. If you have any additional questions, obviously the YouTube chat is going to go away. If you have any questions, go to our Discord, join our growing community, and you can ask questions there and we can answer them. And our community is really great, and there's a lot of people in the community that know a lot, and they'll also be able to answer your questions there too. So go ahead and check that out and subscribe if you are interested in any of our other videos. I think I said that twice already.
Yeah. Please.
All right. So with that, thank you so much for joining us today. We really hope that you enjoyed it and learned a lot. And we will see you next week for our next workshop. See you.
Yeah. See you. Bye.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.